Thanks, everybody. Morning. Today we're going to talk about building observability, as I mentioned, but we're going to do it in a different way. Rather than talking about metrics, logs, and traces, we'll start working on how to diagnose and find problems, and how we can slice and dice to find the right metric that can help us solving some challenges. So you can complain about the drawing skills later. There's 3 blocks, mainly on diagnose, but we have also how to uncover hidden issues and prevent. Mainly the bulk of the talk today will be on diagnosing things and stuff. We just have 30 minutes and we have to pack the whole session. Probably uncover could be a potential lighting talk, or we have time, I will try to speed up and show a few things there. But let's start on what we're going to see from a diagnose perspective. We're going to talk a lot about dimensionality, how we slice and dice to find the right metric, but also we're going to look at finding patterns when we're working with high cardinality. When we have thousands of time series and stuff, how can we really make it easier as when we troubleshoot with low cardinality metrics? And then we're going to use tracing to build service map to help us identify the components out there. Because today we are in Malaga, we have a sunny day, we are close to the beach, we are going to navigate the seas of observability here, no? So welcome all very abroad. And we start with having a problem already. We don't know it yet, but there's a leak in the boat somewhere down in the ship hulls and stuff. How can we take this when these things happen in our website, for example? So we're going to talk here about an e-commerce application. We have here the teams of developing. You guys will be doing the product side, search engine, and probably the shopping cart. Huh? And we already know that there's a problem in the shopping cart. I will say, how, if we didn't even start? Because we're getting a lot of complaints on customer support calls. People is not able to place orders, their thing, and it's a shame that our teams didn't even notice that there was something happening, no? How many times you found that you know there's a problem just because the customer is calling there? No? So where do we start? From a starting point, let's see, what if I take the site-wide error of what's going on in our website, and we have our alarm threshold there, but we don't see anything. But the problem is right there. Huh? Maybe the guys in the back can see kind of a pattern looking. Maybe in the front is quite more difficult. But we have our alarms that are even silent. Nothing happening, but the error still keeps there. What we are going to introduce here, and we're going to talk a little bit about things, it's going to be on dimensionality. This is a way of looking things from different angles and perspective to really find where can be our problem. It's kind of show me latency, errors, and stuff like that per dimension. We have a website, but we're going to look into the different web pages that we can go there. And because we start getting all these calls there, we're going to look if it's the shopping cart, maybe on the product side, because the products are not linking correctly in the shopping list and stuff like that. We'll bring both. Here you have 4 time series because we're looking to 2-page, 2 dimensions. That's what we get there. And now we start seeing few things there. Like we have so many requests on the product side and successful that it downgrade what we were looking on the error cards. If you see the error cards, we have requests and it's slightly growing and close to the threshold, right? If we put this elementary math, how things work, product errors divided by the total overall request, that's the graph that we just showed just a few seconds ago. If we split and we look on the product availability and the cart availability, it's starting to see it's clearly a problem in the cart side. So you guys will rely on you on the rest of the talk because we're seeing that kind of spike. We usually plot different dimensions into the same axis to see how things are going. Here we see the product errors are quite flat, but we're seeing that the cart errors are things, and we usually overlap. Maybe it's in the search or it's another kind of problem, we will overlay different layers to start diving if it's an independent issue or it's a commonality happening in our website. So we define our thresholds, 1 for each. Nice, now we have an alarm because it went up and it starts ringing. Now we start knowing that something is happening there. But everything that happens in the web page, because we have the products, the cards, browse, everything that can fail separately, we need to measure separately. So we'll start creating alarms for every single thing. And we had alarms on the cart, which is nice. But what happens when we have an overall outage in our website? A lot of noise. This can become really confusing on seeing what the heck is going on. And here's where we introduce something called composite alarms. So we roll up into a single alarm, something that triggers out when simultaneously happen across everything. So we try to decrease that kind of noise and really focus on what really matters. Here's what we have. And you might say, well, Guillermo, but we have just 5 alarms. Who cares? It's easy to manage and think. But for every dimension thing that we are looking at different. We're looking at latency, errors, volume request, really measure what it's really important for our customers and can degrade the user experience in the website. So the first takeaway, this is the format we are going to use for takeaways in this intro, is split key application health metrics, separate dimensions for each customer use case. That can be per web page, per widget, and then let's combine many alarm signals together. So to avoid a fatigue by using composite alarms, on AWS we have a service called CloudWatch, and it suddenly went out. Oh, no. So we're going to see 4 failure modes. Let's get now into the funny part. We can have bad dependency because every single component is rendered and coded in a different manner because there are multiple teams, and maybe we want to use those components across different websites. We're going to start looking on that part, but it can happen also that we have a bad component, for example, the underlying infrastructure that is affecting our shopping cart widget, or maybe it's just a bad deployment. Someone just pulled a new release and it's creating some bugs on the production side, or maybe even a traffic spike. This one is, ironically, can be a failure mode, but it's usually successful that more people is using your website. So we should be happy on getting that kind of increase. So if we start with bad dependencies, we have here again our shopping cart. However, the exact reason remains unknown. We know that something is going on. Maybe the rendering, the logic of the widget is not working, the infrastructure. It's like how we can approach this thing. If we get back to our ship, usually we'll probably have different water sensors all around the place. You need to have it correctly labeled because you can have thousands, but we need a way to visualize those things. If we're able to map the whole thing, now we can know that we have a problem in the back bottom of the ship holes, and that's where we're getting the water. How we take this into our website, in our e-commerce application? Well, we're going to talk, as I mentioned, there are different teams here, microservices, we want to refactor and use things on other places. Everybody is using them because you have the ability to select your storage, your type of indexing might be different from one component to another. We know things were happening on the order side because we have this first attempt of the cart errors plus the customer call support, and we're going to zoom in and start looking just at this specific component here. So if we zoom, we get our architecture. We're going to talk about tracing. So what tracing is all about? When we get a request that comes into our front door, in this case our application load balancer, we're going to put a stamp in the request. It's a unique identifier that is randomly, and what we're going is to pass the token through every outbound call that we have in our systems. So as we go through components, we will be able to trace in and log in what's happening there. So far, so cool, because now I have a bunch of metrics with traces showing up things that are happening. But it's quite weird to get someone to go and operate and try to look. We need to find something that can centralize and aggregate all these metrics. You can use open source tools like Jagger or probably X-ray services on AWS to concentrate and aggregate all these things. The good part is that these services are able to map automatically for you the health and status of the different components, kind of red, yellow, green. And now we're seeing that we have this problem on the ordering service. So if we look back, kind of using the same approach as the sensor detect, now we have our dashboards with the whole thing. And this is not just on a PowerPoint stuff. This is how it looks if you go to the service. It automatically creates the dependencies, and we can see the health, we can see the traffic. we can just go and say, okay, we've just seen errors for the last 5 minutes, let's just change it. And you will see a red signal on one of the components that now you can deep dive and start digging and find what's the root cause and what's happening with our shopping cart. In this case, it's in our site on Amazon.com. So let's take a couple of takeaways out from a bad dependency here, right? First thing, we need to propagate all the incoming trace context to every outbound customer call to make the best of every dependency connection, right? We need to enable all the trace segments from all the services into a centralized place. And then we will use service maps derived from those traces to triangulate and failing dependencies during the incidents. That's first way to diagnose things coming. Let's work on, maybe it's a bad component, maybe something on our EC2 instance or web server fleet. Let's see what's going on. If we get to this web server layer architecture, we have a bunch of web servers, in this case, 9 EC2 instances in different availability zones. And usually the user request will hit our load balancer, and the load balancer will pick the algorithm that we just configured, maybe list connections, maybe IP hash because you want to have persistent for the shopping cart, or whatever. So it takes this EC2 instance that will render the HTML back to the customer, but it does something that at this point we don't care, and it throws to the backend. What happens when it goes out of memory and crash? You will say that we have a big issue here. We get a site-wide error rate, 11%, 1 out of 9 servers that we have. We have a disruption in the service. Thanks God, web servers are, or load balancers are better than that, and they have this feature called health checks. If we configure correctly the health checks, we will be able to start pinging, and you can have like a blank page just to get a 200 OK status code inside a time frame. If it pings and it responds correctly, mark healthy. If it goes off the time frame and gets some different status codes, unhealthy, pull it out of the web server fleet and reroute things to the next EC2 instance. And the way we will see it when we operate the whole thing is just a blip in the graph, which probably nobody cares, right? What if we go down to different kind of failure? Let's talk about deadlocks or grave failures. This is the way that you have an operational status service, but wedged in a weird way that something is failing. Let's say we have an HTTP client library that is fetching from a third-party API, and somehow, sometimes it doesn't connect, it replies with a low request, failing, intermittent. It's like, well, but I see that it's operational, but the user experience is getting worse and worse. So there's a lot of things that we can talk about health checks. I put there a QR code that it's one of our wonderful blogs that comes into the pros and cons. It really dives deep on how to configure this correctly. But what we are going to see is a site error rate going up and up and up. Maybe it's not hitting yet our thresholds, but we are seeing that there's a tendency to increase. If we go and see the telemetry data of what we have here, we can see that increment thing going on over and over, right? What tool in observability can we use to zoom in a little bit and drill down to what's going on? Dimensionality. So first we thought about web page. Now I'm going to look around instance IDs, and I want to see the errors we're having on each one there. If I plot them in the same axis, I'm seeing that, hey, instance ABC123 is the one that's creating some problems. We can dive deep and start inspecting on what's going there. We could probably put a threshold for each one, and you might say, hey, let's take what G was telling us before about composite alarms. You can do it, but I wouldn't suggest, to be honest, because every time you will have a new instance coming live, you will have to get the instrumentation and automation to just pop it up and create the alarm for you. I think there's a much better way to come and do these things that is using insights query and alarm. We can just use a SQL query and ask, identify the top 10 most failing instances that we have in our time series, right? But that gives me just a graph. It's not actionable. Now I can see that the problem is there, but really I want is to have an alarm to show me that something is happening. We can do some math expressions playing with this and say, hey, why don't you give me the failure rate of the most one that exceeds 1% over 2 minutes? Maybe that I can have my alarm and start identifying things. So rather than having the bulk of individual, just go and query and get those things up. This is how it looks when you connect to the console. You get all the graphs. If you get on the right on top, you have the query button that will show you the query that we have. The good things are that nowadays you don't even have to know how to build queries, because we introduced natural language processing using AI services. So now you can tell him, hey, show me the top 2% are having most failure requests on stuff like that. And it will generate the query for you and show up in the graphs. So let's see now a different type of challenge. We have our product teams that have been thinking on how to save some bandwidth, cost, and latency. So they create this kind of cache layer where they have cache nodes per availability zone. That's very nice. Our web servers, they connect to the cache, they get the product thing up there. But what happens if one of those cache nodes goes into a gray failure mode? Again, that will impact the whole availability zone and will roll up to the web servers that will start showing up that, hey, there's errors happening there. Problem is how we see the commonality of what's going on, because it's impacting on the cache node, but the effect is being seen on our web servers. What tool can we use to find this whole thing? Hope you start guessing what we're going to talk about. Dimensionality again. What if I take now and I talk, let's look on the availability zones and let's see the errors and rates that we're having there. So when we detect those things and say, okay, the availability zone, I can just go and use Route 53 application recovery controller to tell, hey, stop routing traffic to that availability zone. So now what we are doing is we're improving the recovery time and getting a better experience for our customers. We detect, we turn out, and once it's available again and they fix the cache stuff, we will be able to include again the availability zones there. So takeaways on this one. First, split the key application metrics, separate dimensions by infrastructure boundary. We can talk about easy to instance or availability zones. Additionally, we can use insight queries to look for the poorest performing part of your infrastructure rather than having the whole thing there. Now, we saw components, dependencies, but deployment. How many has pushed code into the infrastructure and suddenly you get a call that something is not working? Usually stuff because when we start deploying things, in the old days, I had to pull up different dashboards, start looking after, oh shit, I saw in the change management ticket that someone did a deployment yesterday night. I called the guys, no, it's not our fault, it's yours. Maybe in some other place inside the network. Look up. And you need to start diagnosing and fighting with everybody to write. That's time that we lose, and that's a problem on the availability of our website. So let's get back to our ship. We are sailing our ship here in the Malaga Bay, but the wind is going cross, and our ship is going a different direction. And what we want is to start speeding and put the ship in a way that we can take advantage of that wind. So I will ask the product teams and the guys in the shopping cart, hey, let's start pulling the ropes. Release, retract, put it on side. We start moving our boat. Suddenly it gets too windy and starts getting shaken. It's, oh my gosh, we're having a problem. Bang, we dismantle. End of our journey. Well, we can try to do it quite a bit better. Let's try to do it a second time and see how it goes. Now what I'm going to add is a monitor there that can help us. When wind is coming, we have a couple of sensors. So again, we are trying to fit and put the boat in the right place. But suddenly, like, oops, when it starts shaking, there's an alarm as we put it on pressure and movement. And it's like, oh gosh, this is getting critical. Let's do it the way around. Let's roll back, retract, and let's put again the sailboat in the right position. We get yellow, but still a warning. Good. We took it back to the original state. We are good to go. What happens when we are troubleshooting our e-commerce side? When there's no kind of rollback, and here we're doing quite a good thing of a resilient perspective because we're doing incremental deployments, we see that the error starts growing up. First grows, wave one still growing, And then when wave 2 and 3, we already have the alarms and the threshold. But when we do this manual rollback, the guy looking, investigating, he has the alarm, let's see what's going on. Oh shit, let's start investigating, calling people, because you don't have, right, the whole end-to-end vision there. And there's a point that he realized this deployment happened and starts thinking, okay, I'll take the decision to roll back. It takes time, so there's a big portion of what we call time to detect, time to mitigate. Mainly those metrics is what we use in incident response, right? How can we shorten things? Because all this affects reliability of our website, but also the customer experience. Well, we'll introduce things about automatic rollbacks. Let's say that we're doing code deployments, and I need to also deploy infrastructure as a code. So every time we get into one of those components, we can configure into a single component inside that stack that if something goes weird, just automatically roll back for me. So you get the alarm, you get the rollback. Don't use human intervention. Just set the alarms and how it goes, and one thing fails, we recover back. Many, many years ago, I was working for a big carrier operator, and one of the biggest centrals went down, and all the emergency calls were connected to that central. And suddenly, the local government was complaining about, oh, we're having dead people because they cannot call to emergency service. People is dying, it's your fault. They were like, oh my God. And I remember our level 3 support in Madrid trying to find where the problem was. It was like, it's not trying to find, it's trying to resolve. Let's fix, and then we think where it's the whole thing. So I throw down the whole central. I got a lot of calls the day after from a lot of managements inside the company. And we pull up, we route it through other place. Emergency calls were back. We are good to go. Now we can start investigating. You need to balance. When they start talking about a lot of millions and stuff, or people dying, you should take that into account. Huh? But now we're shortening the time to mitigate because we're rolling back. And even it's better because you will see now that I was talking about infrastructure as a code. This is how it looks in the screenshot when you're doing CloudFormation. It's one of our services that helps on deploying your resources in AWS. Every single component can have a rollback. I just put a monitor in there, something happens, do it for me. And the cool thing is that now that even shortens because I don't have to go over the whole fleet. I just go for a single component and I get it back into operational state. But we still have a problem. It's like time to detect is still there. Alarms are happening. So what tool can we use to deep dive and try to drill down on the right metrics and stuff? I get that at this time, we already know that dimensionality. Again, now I'm going to look after the code revision. Usually you will have 1, 2 code revisions that are put on deployment. And let's look on how things happen. Brown, I was going to say blue ones is our old code. Just a blip there, something happening, but it's quite flat. The new code, which we didn't have any information because it's just new, literally spikes up. So that you don't need to be a data science to see the shit. The problem is in the code deployment. Now we can have the alarm, auto rollback, bingo. Now we're decreasing the time to detect plus the time to mitigate. And this correlates to the user experience on our side. But how we can implement things, because we have alarms for the old code, the new code. I want to have the old code also because maybe we have a serialization and we have a bug that affects new versions and previous versions and we're breaking things. We can do, again, composite alarms. We can roll back everything into a single one to avoid a lot of noise there. If, however, you get a lot of noise coming from the composite alarms, maybe you need to fine-tune that the problem is the way we configure, not really the alarms that we're putting up there. So, third mode of failure, what are the key takeaways? In this case, let's split applications by logical boundaries. Let's say we're looking after the deployment IDs to minimize the time to detect and resolve things. Rollback, all type of changes automatically. Maybe you say, gee, not everything needs to be rolled back automatically. Well, when we're operating in very large distributed system, it's much better just to roll back and then try a second time than just going and finding that things are getting worse and worse. And then combine literally all of your alarms into a single composite alarm. just to help triggering all those things. Huh? And now we get into the final failure mode, that is traffic spike, which I said at the beginning, it should be a successful thing, that more people is using my website and looking for products and ordering and doing stuff there. Let's see the flow, how I would detect that, oh gosh, I got on a latency alarm. What should we do? We have our service map already there. We see the components. Oh, here is a component that is yellow, and it has the average latency that has grown up. Does it has grown up because someone has done a deployment in the last 24 hours? Yes, no. Well, looks like the last time was 4 days ago. So maybe the error comes there. Usually there are also some hidden things that you start seeing problems 2 days before when things happen. But now here I'm going to look more on other metrics inside the dashboard that we have for latency. The fleet CPU is going up. Is that because I'm losing host? Are we getting anything out? Doesn't look like, because the fleet is growing up. Maybe it's auto-scaling and we're correlating, and now the fleet is growing and the amount of requests is growing, and we see that spike coming there. It starts to get in like a bit confusing and overloading situation. And with all these request volumes, if I want to dive and see what's this delta, I don't know where it's coming the whole thing from. Do you know what kind of tool we can use to drill down and find what's going on? Again, dimensionality. Because the thing now we can use on the customer IDs per request that are having up there. And you might say, oh, look all the dimensionality we have already there. G started from a website. This is what we call cardinality, just starting from few things. We have one website, couple of code revisions, few availability zones, but thousands of customers' ID coming out there. And if we just go and say, hey, let's plot all our customers to see which are the top requests going there, I don't even have enough pixels to show up all the customers having those issues. Like, how can I detect this whole thing? We're going to talk about contributor insight. It's like, hey, why don't we just take the top 500 that we have there and continuously monitor at any point of time? Because what we really care about is those customers that are making the most requests of. And this is how it shows. If we get it on contributor insights inside our services, it will show up and put it there. But we're going to talk at this point a little bit about telemetry. In CloudWatch is the service that we have to monitor and log all the events. When we have our application, we try to instrument in a way that we can log everything out there. And we will use a structured log that we'll put there, so we have all what's happening in the application in this log. We'll pull that into CloudWatch and to the log side, and it will start generating automatically metrics based on how we configure it, taking up that log. But it also, from those metrics, our site server side, we will take and create alarms for you. So now from the structured log, we went from a simple thing that I'm recording to build up those metrics and those alarms for us. How does it look? A request on the log entry. Well, kind of JSON, something simple to parse. And we have here two things that we can identify. We have on the first thing, things about the request, who is the customer, what's the instance, type of operation it's going on. But we also have a portion that is things that happen during the request. How many times it hit a cache, failure, or whatever. Using these contributor insights, we can just create a rule that says, hey, count me for every customer ID and count and map everything and put it in a single bucket, so I can have all a single customer, what the heck they're going and doing. And it will show that kind of spike on the top customer requests that we have. Really focus on what really matters on measuring. I just want the top ones that are creating this request per client IP. Even you can do it by identity. If you know the identity, you can almost track on that area. But we talked previously that we have those 500 metrics that we are logging from our customers, but you can do also in-flight rules. You can create filters. You have that information available. You might not be using everything, but now I can create a filter saying, hey, for these customers, I want to see all the counts for the every 60 seconds and show me how it looks like. So if you have your level 3 teams troubleshooting and going deep, they just can go on the fly and create all these filtering things. Huh? So takeaways from traffic spikes, emit the logs that are rich with data so that you can plot the metrics on many, many dimensions, record and analyze high cardinality metrics, and keep the volume using contributor insights. And then slice and dice. It's always about how I put my cake in different portions, so you don't even materialize things that were up front. We can create the log inside queries there. So in this short 30 minutes, so they're just with the end tablet there, we just saw how we can use dimensionality to compute the right metrics and find what things are going on. But we also found those kind of patterns with high cardinality and how we can treat them as low cardinality by using the customer insights. And then how we use tracing to build our service maps and navigating. And so far, I would like to tell about hidden things when things happen on your CDN and stuff, but probably we'll do it for a lightning talk, right? Thanks very much.